On? Can you hear me back there? Hello? Hey, Unite. Hey, all right, yeah. How about Unity, huh? Isn't Unity awesome? I wasn't planning on starting that way, but it's all good. So hello, welcome. I'm Brian McRae. I am one half of Fenix Fire. We're just a small indie development team, and I'm here to show you our game, Gates of Osiris. The name of the talk is High-End Mobile Development, Postmortem Practices and Performance. And I have to make a confession here. It's a little bit of a misnomer because the game's not out yet. So just strike that postmortem part, and then we're all good. But I do want to talk about the high-end part of it. And what I mean by that is high-end devices. There's a lot of new devices coming out specifically for Android that are really pushing the boundary. Are we good back there? Okay. And so you could do a lot of things graphically to really push these new systems. And I'm going to show you a lot of tips and tricks on how to do that. But before we get into all of that, let me just show you a little bit of our game here. I have this little video we put together last night. Notice we have full, real-time shadows on the vehicle here. This is running on an Android tablet. Everything is normal mapped. Everything has 2K textures on it. We have a lot of different modes of play, like first person and vehicle mode, and we're definitely having a lot of fun shooting aliens. So that's a little sneak peek of our game. We're having fun. We're geeking out. Thank you. Okay. So what are we going to cover today? I'm going to show you a bunch of tips and tricks on how to push your game's graphics in order to help you stand out in today's marketplace. I mean, we all know that the mobile market is really tough, really fickle right now, and having really nice graphics seems to get a lot of attention. So I'm going to show you some ways that you could do that. We're going to look at Gates of Osiris. I'm going to show you all different kinds of things that we're doing in the game, specifically for Android. Now, these are all actionable items that you could do today. Everything that we're doing here is just in Unity 4.5. So I'm using the same version that you are. I don't have access to 5.0 or anything like that. But I think a lot of the stuff that we're doing here could definitely fall right over into the metal system that's coming over to iOS when Unity 5.0 rolls out. Going to look at the OpenGLS 3.0 within Unity, and that system gets you a lot of optimizations and some really cool things that you can turn on, like advanced shaders and whatnot within Unity, and I'll show you how to flip on all those switches. And then I'm going to get into the art of the game, specifically how we're building our environments, our vehicles, and our characters, and share with you a bunch of the tools that we're using in our production. So a little bit about me and my company. I'm one half of Fenix Fire. We're just a husband-wife team. We're from the AAA publisher space. So I used to be a lead environment artist at Midway and at Blizzard. In fact, the last game I worked on was a game called StarCraft Ghost while at Blizzard. And my wife has worked in the AAA space too. She worked on Silent Hill Homecoming and Barnyard, which was a movie. And she was a texture artist over there. So most of our career we've been environment artists, and then we went indie. And in 2011, we launched a game called Roboto, and we're lucky enough to get it featured by Apple and by Google. So that kind of kickstarted our company. We're also working on a game called Source, which is for the next-gen consoles, and we're having a lot of fun with that. And we're a small team, so we do a lot of work for hire too. Roboto, Gates of Osiris, and Source are all passion projects, but we work with clients like Chevron. We make motion simulator games for them. And we've been working with Oculus. In fact, me and my wife are responsible for the Tuscany World demo that ships with the SDK. All right. Wow. Thank you. Thank you. Yeah. It's funny because we worked on some really big projects like Mortal Kombat in our career, but I think this has actually gotten more eyeballs on it than anything else I've ever done. And I'm also the co-host on a little fun thing that I'm doing with a friend of mine called the Game Design Dojo podcast. All right, thank you. And yeah, it's from an indie game perspective. Me and my buddy Ike, we just jam about game design, the business end of it, marketing. So you could check it out. It's free on iTunes and on Stitcher. So this is a little note to myself to go into the game and show you what's going on. Okay, and I'm going to take the sound down. So here we are inside the environment that you just saw before, and right off the bat, we definitely totally geeked out on our terrain. We're actually not using the Unity terrain. We've modeled our own, and I'm going to show you how we did all of that. And we actually went really crazy on the shader for this. So we're blending a bunch of different textures together to get this effect. We have a distant texture that has all the erosion and detail for the distance, and then we have a couple of detailed textures that we blend between, and you can see that here, the two different detail textures. All the normal maps and everything here is a 2K texture with normal mapping. But all the ground textures are using parallax mapping, which forces the bump just a little bit more and gets us more of that 3D relief kind of feel to it. We also have specularity on the ground. It's a little subtle. You can see it get picked up in some places more than others, but it's in there. And so the sky is just the all sky system. It's a Unity asset store package that we picked up. We're huge on the asset store. We're always buying things. In fact, the camera that I'm using here is ultimate first-person shooter camera. So like I said, we're a small team, so we try to leverage as much as we can. All the rocks here, I think, are from a rock pack. But anyway, yeah, then we just rendered some planets and some moons and put that into the skybox there. Something else that's really nice that you could do with the new Android devices is you could turn fog on, which we all know historically has always dropped your frame rate in half, and now we're putting it in, and there doesn't seem to be any kind of an issue. Let's go ahead and jump into one of these vehicles. So this is our hovercraft. We just put it in. We just finished it yesterday, and this is using the Unity physics system to drive the actual hover of it. So you might think that this is something that just has like some kind of a character collider and is just going over the terrain. But actually what we do is we have 4 different points on all different parts of the vehicle itself that are pointing down to the ground and then putting some kind of reverse gravity up to get at that buoyancy, which is kind of cool. The shooting that we have, we went really crazy and really optimal with all of that, and it's a little bit more prevalent here in the what we call the GAV, which is the ground assault vehicle. And here, what we're doing to get the particles is we're not instantiating every time we hit the ground, because that would just kill your frame rate, and you get all kinds of frame hitches. What we actually do is we have what we call the effects manager, and there's just one particle system for every time we hit something. So when we're hitting the rocks, we're emitting from the spark emitter, and then when we're hitting ground, we're sending messages to emit from that emitter, and we're just moving that emitter around in the world to then achieve that. So there's only one particle effect for each kind. And then anything else that's using these, like if a creature is hitting a rock and it's creating a spark, it's using the same, they're all sharing the same particle systems. Another thing with the particle systems that we're doing here is we're raycasting into a texture, or actually the large texture that covers the entire terrain, and discovering what color is in there, and then finding those pixels and modulating that into the start color of the particle system. And it's all just stock stuff that you could do within Unity. You have to do something like make your ground texture readable. But once that's in there, then you could do that, and then that way you could get your particles to kind of match the environment a little bit better. And because this terrain is our own system, we're rendering our own light maps, or I guess putting them in a different way. We are using the Beast light mapping to get the light maps the way they are, but the only thing that is light mapped in the scene is just the ground. Everything else is being dynamically lit by one light in the scene, and that's that sun right there. And the reason that we do that is we just find that, and we played around with this stuff forever. How Unity has directional light maps, and then they have the dual light maps and all that kind of thing. We just find that we get more bump, a little bit more of that detail when your models are being real-time lit. And it seems like if you just have one real-time light lighting the entire scene like that, it doesn't have any frame rate implications. So you can have that in your scene, and it doesn't hurt the frame rate at all. And of course, on the vehicle itself, we're running a shadow in real time. Now, I know I'm running this on my computer here, but this does run on the Android tablets. And it makes such a huge difference to see that real-time shadow. We've tried the blob shadow stuff, and it looks okay. In fact, we use that for a lot of our enemies and creatures and whatnot. But just having the shadow in here really helps. So let's go and show you how we did a lot of this stuff. So first of all, let's knock out the OpenGLES 3.0 stuff. You just go over to the project settings, player. Obviously, you're over here. We like to use the forward path. You can use deferred lighting if you want to do multiple lights, but that's if you're doing a really small scene. We're finding that with our big scenes and lots of characters, that forward is the best way to go. Multi-threaded, you want on. Static batching, dynamic batching, you want all those on. GPU skinning, we've been turning that off for now. It seems like some higher-end devices are actually, that's hurting the performance. So until that gets straightened out, we're leaving that off. And here's where you're at right here is graphics level, force OpenGLES 3.0. You turn that on. Once you turn that on, you might be getting a lot of errors in your console. So if that happens, head over to here and go to graphics emulation and say no emulation. Otherwise, you'll just get a bunch of warnings, and it's no fun. So what that gets you is a bunch of really high-end shaders that you could start putting on, such as here's the shader that we're using in the terrain, and you can see here we have a main texture and a normal map for that main texture. Both of these are 2048. We have our two detail maps with their normal maps, and then we have a detail mask, which I'll show you how we got that out of a standalone package, and then our light map that Unity gave us, along with our spec and whatnot. So some really cool stuff in here. And so let's dive into exactly how we achieved all that. So this is a separate program called World Machine, and this is how we're creating all of our terrain. And what's nice about this is, well, it's not very expensive. I think it's under $100 or something. You can, just with a few parameters, change it around and get all kinds of different terrain elevations. And get different kinds of erosion maps and whatnot. So this is something that you don't need to be an artist to use this program. You could be a producer or a programmer and still be able to kick out something like this. This took only like half an hour to put together. And once you have this, you get some really cool things. Like, for instance, you get not only the mesh, but you get a color map, you get a normal map, and then you get these cool things like elevation maps and then also erosion maps. You can then take that, and we put that into Max. And this is just the displacement on a mesh in Max. And if you're familiar with 3D Studio Max, you know that over here on the left, you can parametrically change the resolution. So here's the resolution that we're using. It's just a big quad, and we're setting it to 128 by 128 for the vertices, and which is pretty low res for the size that it is. You see it's 16,000 vertices for the entire scene. So that's what we're rendering. Now, this could be optimized even further by chopping this into a bunch of different parts and using the occlusion settings inside of Unity so that anything behind you doesn't get drawn. So that's something that you could also do. But we like this because then at this point, if we're exporting to like a lower end or even a higher end device, we can just crank this up, spit out a new FPX, and we're all done. We just bring that in and change that up. So, and then also you could see that this has the normal map applied, which it spits out this world machine, gives you a beautiful normal map. It's pretty amazing. This is the detail of the shader. We're using Shader Forge. We've been using it for a little over a month now and just have fallen in love with it. It's pretty awesome. The main piece of this shader is right here. This is the engine that drives the whole thing, and this is your distance. So what we do is we kind of measure the distance from the camera out into however far we need to kind of measure where we need to start interpolating between the detail maps and the distant map. And so there's a world position and a view position right here. And that gets fed into all of these pieces right in here, which is just some further math, and then that gets routed into all the color stuff up here and all the normal stuff down here. And then over here is our parallax settings. That just amplifies the normal map a little bit further. So pretty cool stuff. On the character side of things, there's really no way around it. You need to roll up your sleeves and crank up a program like ZBrush or Mudbox. This is a creature that I sculpted in ZBrush. It was definitely a fun 3 or 4 days just going crazy on this thing. We wanted to create enemies that you just wanted to destroy right away. Like, yeah, that thing's ugly. I just want to kill that. So, and we also wanted to do something where we have a system where we could blow off limbs. And that's something that we have in the game here. So you could actually shoot off limbs on this thing, and he'll come and attack you with only 3 legs, which is kind of cool. And then when he gets down to 2 legs, he can't go any further. He just starts going crazy, which is kind of cool. Anyway, yeah, the process is you just make something like this. You export a high res. You make your low res around that. I usually give it to my wife. She makes the low res version. And then we use a program called XNormal to extract all these normals and an ambient occlusion map. And that becomes our texture for our low res. We do the same thing with the vehicles, except this is all hard surface modeling. So we just stick within 3D Studio Max. These are our vehicles right here. The big one in the middle is what we call the dropship. And then we have the tank. These are all the high-res models. So these are, I guess altogether, they're 424,000 vertices, which is not that crazy. But, kind of go nuts on like the tires, getting all the little knobby parts on those and all the little details and whatnot. And then you just kind of go back and forth on figuring out like, well, what gets put into a normal map and what gets a model. And what's cool is you can kind of sniff out what device you're on and then turn certain things on and off. So for example, on this vehicle right here, those tires are really expensive. They're like 2,000 vertices each. And so when we try to put this on an iPad 2, it's just too much for it. So we have a script that we just attach to certain models. And then we say, hey, if you're an iPad 2 or lower, switch it with this model at runtime. And then we'll just switch it with like a cylinder with a nice texture on it. And that's sort of one way that we could always ensure that when someone's playing the game, they're getting like the best experience, the most performance that they could get. And then here is the hovercraft, which we just wanted to make it look sleek and futuristic. So some asset store time savers. We're using Eddie's vehicle physics. So definitely check that out. He's done a fantastic job. We modified it a little bit to get 6 tires on our GAV as opposed to the 4, but it's pretty easy to do that. One thing that's a little bit of a quirk is all of his comments are in Spanish. So, crack open your Google, tool that does all your, translation for you. And then you can get through that. Shader Forge, really great program. We used to write our own just in, CG, that fragment shaders and stuff. And it just takes so long. And this Shader Forge, once you get the hang of it, it just goes really fast and it compiles everything for you, and it's just fantastic. So we have it now we're not looking back. Ultimate first-person shooter camera, really nice. Oh, and by the way, none of these people paid me to say these things. This is just something I wanted to share with you because I'm sure a lot of you are like us. We're just small indie teams trying to, make a living doing this, and these are just time, lifesavers, really. Input framework is a really nice tool to detect taps and swipes. And then, the list goes on. We've been using EasyGUI for a long time. And then the useful stuff over on the right, we have World Machine, XNormal, since I mentioned before, and then something I'm going to mention next, which is the Adreno Profiler. So this is the profiler from Adreno. This is actually a Qualcomm system, and you can download this for free from the Qualcomm developer site. And this sort of takes over where the Unity profiler leaves off. So this is all running real-time on the device. And what's nice about this is you can be running your game. It'll take a snapshot and show you all the textures that you have loaded. It shows you all the draw calls that you have down here, and the red ones are highlighted as being very heavy. See, it says heavy right there. And then it'll give you some tips on how to optimize it further. And then what you could do is you could actually start turning off some of these draw calls to see what kind of frame rate you're getting while it's running, which is really cool. So how you would make a build, put it on the device, change one thing at a time just to try to dial it in. I mean, that could take a super long time. And then with this, you just kind of throw a lot at it and then see how you're doing, and then just give yourself a couple hours of geeking out with this thing, and then you pretty much have it all dialed in. So it saves a ton of time. Over here, I just wanted to show this. This is all the different textures. And it'll show you what format your texture is in. And it's important to take a look at this. The new texture format that is really nice is called the ETC2 texture format. So remember that, ETC2. You can get to that by going to your texture. And if you, you go to Advanced. Got to go to the Advanced tab. Open this up, and it's right here. 4 bits if you don't need alpha. You have the 1-bit alpha compression, which is kind of nice if you just want an on and off on your alpha, and then the full 8-bit alpha right here. So you could use these 3, and it gets you some really nice results and crunches it down pretty good for you. And what's really nice about it, in addition to it gives you a better look, is it runs fast on the device. So here you see here this terrain, really sharp looking and everything. You see lots of detail, and it runs really, really quickly on the devices. So definitely check that out. You also could set up all these different graphs. So all of these are just kind of you drag them in and set up any kind of graph system that you want. And what you want to do is kind of figure out if you're CPU or GPU bound. And I guess what I mean by that is If you have a lot of AI and processor intensive stuff, and then your GPU is waiting for all that to keep up, then you're CPU bound, or the other way around. Like if you don't have a lot running, but all your graphics are really expensive, then you're GPU bound. So what you want to do is kind of equal those out so that you're doing the maximum amount you possibly can in your game. And this gives you the tools to do that. So just to recap on the profiler, you could see which textures are being loaded. You could determine if you're GPU or CPU bound. You can identify your high-cost surfaces and eliminate the guess and check that comes with making builds. So we've been working on Gates of Osiris now on mobile for about a year. We're also planning on bringing it to other platforms. And what's kind of cool is we're seeing that the high-end Android is getting right there to the to like PC. So these are just some of the specs that you might want to take a look at. 100,000 vertices, 100 draw calls, gets you on a lot of systems. Once you turn on shadows, it's going to start cranking up your vertices and draw calls. But on the new devices, you could get pretty far. And we're using the Qualcomm 805 processor, which is pretty nice. And then just really quickly on some modeling and material tips. We like to put our time towards our hero assets and use the asset store for things like rocks and whatnot. Make your high-res normal map, ambient occlusion baking for all your high-res assets, and then low-res versions for your game. And then you can always change all that. And then once you get that all in, try different things like LODs, scripts to detect what you're running on, and then have fallback materials. So just to recap here, this is all the stuff we talked about. We're kind of running out of time, so I just want to open up to questions. So thank you. Yeah.
Could you go quickly back to that awesome list that you had up there?
Sure. You mean the video?
No, the list of the different programs.
Oh, yeah.
Awesome.
This one.
Yep.
Yes.
Have you guys used the quality settings in Unity to kind of tweak which devices kind of which quality settings?
Yeah, so he asked about the quality settings in Unity. I could show you how we have ours set up. It's basically for Android, we have it set pretty high. Project settings, quality. So you can see we have it set at beautiful, but we have our shadow distance set at 20. And we're actually changing our shadow distance on a per scene basis. So some scenes, we actually increase the shadow distance because of performance reasons. So it's something you can do at runtime, which is kind of nice. Everything else is just kind of full res textures, anti-aliasing disabled. Yes?
You mentioned using LEDs. I was wondering, in your practice, how many levels do you normally
Yeah, for things like rocks, what we'll do is we'll just have like the full res, a low res, and then nothing. Otherwise, it just starts taking too long to like model all those different types. For things like enemies, creatures, and things, we don't have any LODs on them. We just figure they're already expensive enough. Just leave them in there, and then what we'll tune is the amount of enemies that are, in the game. Yes?
How many triangles was that base mesh we're looking at here in the environment?
Let's see here. I'll just run it with the stats on. So you see it's 74 draw calls, 138,000 verts. And as soon as I get over here to this vehicle, you see that the verts go way up and the draw calls go way up. And that's because of that real-time shadow. If I take that shadow off, then it goes down pretty substantially. So you do need to leave a lot of room if you want to have it. Putting that shadow in is like taking a big plunge, essentially. but it does add a lot if you could get away with it. Yes?
Do you find that there's a lot of parallels between the profiler and Android compared to iOS as far as?
You'd be surprised. I think the Unity profiler is a little, I guess, generous. When you get it into the Adreno Profiler, you'll see that you have a lot more vertices than you thought you did. So,
But do you use the Adreno Profiler to get information on how to improve iOS performance?
no, it's only for Android.
So there's no parallels there where you can learn something from the Android and then apply it to iOS?
No, I think you can. I think whenever you put into Android, you can bring over. In fact, that's what we do a lot of the times is we find it's just much faster to develop on Android, and then once we have everything going, we just send it over to the Mac, and then we start building, and then there's usually just a couple of things that we adjust there.
What are you using to profile on iOS other than Xcode profiler?
And that's it. Yeah, I wish there was more, but maybe with the new metal system, they'll have something cool. I don't know. They need something. Yeah. Okay, anyone else? All right, guys. Well, thanks so much for having me. It was a pleasure talking to you today. Have a good rest of the night.